All right, so we're on 8.2. Yesterday 8.1, we talked about our basic parent functions and then just the f of x is equal to ax squared. All right, that was yesterday we looked at. Today we're going to step it forward just a little bit and we are going to add on a plus c onto that. So we're going to add on a constant, add or subtract a constant onto the end of what we saw yesterday. Okay, slight changes, just a little bit. Most everything we're doing today, exact same as yesterday. Okay, slight differences. So this would look like maybe something like this: 3x squared minus 4. Bless you. All right, so now we've got that plus or minus something at the end. We talked yesterday about transformations. We'll see that again today. Regina, what was that transformation of the 3? What was that 3 telling us is happening here? Jackson? Vertical stretch by a factor of 3. Okay, that was that 3 that's in front of the x squared. Talk person next to you. What transformation is this minus 4 doing for us?
I know that's not actually this horizontal. Because it's not.
Okay, here we go. Regina, what do we think that minus 4 is doing for us here? What's this minus 4 doing? Connor?
Maybe a vertical translation, 3 or 4 units left.
Close, but no. Because it
Down?
down. It's vertical, it's up or down, right? Vertical is up or down. So it is a vertical translation 4 units down. Because if you think about it, we're taking whatever 3x squared was, and then we're subtracting 4 from everything. We're moving everything 4 down. Okay, so everything is going to be shifted up or down today. We are not moving left or right. There is no horizontal movement still. We'll get into horizontal stuff starting tomorrow. But we're still just looking vertical translation up and down, which means our vertex is not going to be 0, 0 anymore. Okay, yesterday it was always 0, 0 when you were graphing. It's not going to be there anymore because we're moving up and down. Okay. All right. We got to practice graphing. This is the one that we're going to practice graphing. So I want you to plug in those same 5 values: -2, -1, 0, 1, 2. Let's see if we can get these correct this time around.
Why did the other classes not?
You guys kind of struggled yesterday, the first time. Some of us. Just follow order of operations and you'll be fine. Once you get the y values, actually graph it too. Check the person next to you, see if you're getting the same Y values here, and then go ahead and graph it if you have it.
Here, negative 4, 1, 1, 2. Like this is my graph. This is the graph.
Yeah.
Two Y's. Don't bet.
That's good.
Today is
For zero. Zero, that's canceling out that. whole first one.
All right.
All right, raise your hand. What do we get for our Y values here, Tim?
-1, -4.
There you go. There are five Y values. Just like yesterday, that pattern should be there. Those top two and those bottom two should be the same. If they're not the same, that means you did something wrong somewhere. You gotta go back and check. Okay, so we got 8, -1, -4, -1, 8. So if we graph that, of course, I picked bigger numbers than I had available here. Here, up here, and is that U shape. Probably should have counted by 2 or something. But it's that U shape. Okay, that U shape there. Jackson?
So is the rule form of the
Yeah, absolutely. You're absolutely right. That is always going to be that right there. And that's just today. You're right. It is just today. Once we get into tomorrow and we have that BX term in the middle there, that's not going to be the case anymore. But if we don't have that BX term in there, that C value, that's always going to be that middle term. Yeah, good. Okay, any questions about graphing it? All right. With person next to you, I want you to tell them the vertex, the A of S, the domain, and the range, please.
The vortex is -4. Range is X, zero.
Y is
Oh, sorry. So if X equals the vertex, not negative, just the A. No, it's a vertex is a. It's a square of things, so it's 0 and then it's
Okay, there you go. Raise your hand. Tell me the vertex. What's our vertex? Would be here, Tim.
0, -1.
0, -4. Remember, a vertex is an ordered pair. It's a point. So you gotta have that ordered pair of 0, -4 for the vertex. What about our A of S? Here, our A of S.
X equals -4.
X equals, you got that part, but it's not -4 here. Adam?
Oh,
0. X is equal to 0, right? It's that one that goes straight down the middle. Okay, and remember, it's always the X value of our vertex. Okay, domain telling? All real numbers. All real numbers, thank you. And then for our range, Y is greater than or equal to -4. There you go, good. Okay. Again, like I pointed out yesterday, right, the X part of your vertex matches up with the area of S. The Y part of your vertex matches up with the range. That is always going to be true, whether it's yesterday, today, tomorrow, whatever. Okay, that is always going to be true where these two are the same and these two are the same. Okay. All right. So that's the majority of it. Okay. Well, there are a couple things that we need to point out here. So. We're going to look at example 3 here. A little bit more about transformations. And if you recall, we talked about, or we saw questions like this with our linear stuff. where they gave us an equation first and then they gave us a g of x. And they were asking us what transformation was occurring between f and g. So I'll ask you, looking at this, what transformation is occurring between f to g as we go from f to g? Melissa? Yeah, vertical translation down 7. Remember, we ignore everything that's happening here. This is just saying we're taking f of x and we're subtracting 7 from it. So our transformation from f to g is take that f minus 7. So we are vertically translating down 7. Good. Questions on that? We've seen that before, right? We've done that. But then the other part here, and I'll show you the actual wording of it so we're not confused when we see it later. The wording of it is part B, where it says write an equation that represents g in terms of x. So it wants an equation. When it says in terms of x, that just means there's going to be an x in the problem. There's going to be an x in the equation. So they want g of x, but they want an actual x in the problem. This x doesn't count, right? Because f of x is just y. So they want to basically rewrite an equation here that looks like this, right? Like this, but is representing g. Talk person next to you. What do you think that equation might look like? Any ideas here? Any guesses we want to take? Any ideas? Troy, what do you think?
In parentheses, negative 0.5x squared plus 2, and outside the parentheses.
Okay, that's a start. But can we simplify that a little bit? Tim?
Give x equals parentheses negative 0.5x minus 5.
Like that? That's what we're looking for right there. Okay. So Troy was absolutely right. We had that plus 2 and then minus 7, but we can combine those. We can combine the plus 2 minus 7 to get negative 0.5x squared minus 5. Okay. So anytime you see this type of problem and they give you that vertical translation, just take that and combine it with whatever our C value is the first time around. And we're just rewriting it. Once you see it, once you've done it, it should be no problem. Second hour was getting a little confused on it because I didn't specifically talk about this type of problem for them. So hopefully now that we've seen it, we can do it. Any questions on that? Okay. The other thing that we need to talk about is this idea of the zero of a function. A zero of a function. Now we've talked about zeros of the function. We have not called them zeros of the function before, but we've talked about them. The zero of the function is just the x-intercept. Other words that we've used to describe that, we've said the roots of the function. We've said the solutions of the equation. Right, now we've got the zeros of the function. So if we see an equation like this, y is equal to x squared minus 1, pretty basic quadratic. And they want us to find the zeros of the function. We're going to take a 0 and plug it in for y, because they're telling us it's the x value when y is equal to 0. So we're just putting a 0 here and solving for x. And we've done this before. How are you going to find out what x is equal to here? What do we have to do?
Get x by itself.
Okay, we could, but we had another way of doing this. Troy? So you're saying just look at it and think about what the answer is, right? Okay. And you can do that, but they're gonna ask for two answers. And you're giving me one. This is a difference of squares. Right? This is a difference of squares. That factoring stuff's not going away. The difference of squares. This is x plus 1, x minus 1. Now we got zero product property. So x is either -1 or +1. Both of those would be solutions to this, zeros of this function. So anytime they ask you to find the zeros, just plug a 0 in for y, and we're going to factor it. Okay, we're going to factor it. But everything that we see today, since we're not dealing with that bx term in the middle, it's going to be a difference of squares. You might have to take out a GCF first, but we're going to see that difference of squares to get those two answers. Okay. Let's look at a word problem with it. Okay, try to get the picture in there because everybody likes pictures. You know, very important to see the fake building.
I like the thing.
Thanks.
I like that little guy.
The person sitting on top of the building,
Oh, like, oh no.
little scary there, right? That's, there's
Oh,
no railing, there's nothing.
It's only
That's not a, no, that's a person.
$20 years ago, he's praying. What?
On
top of them.
He's gonna tie off.
Just do it.
That's weird. Anyway. Hey, anyway, here we go. There we go. So they give us the function, right? -16t squared plus this s sub 0. Well, they tell us, right? After it's dropped from an initial height, s sub 0. So they're telling us that that represents the initial height, the starting height. Okay. So then they tell us the negatives dropped from a height of 64 feet. So that just means I can put a 64 in. Right? They tell us that information so that we can fill it in. Now it looks more like what we're used to. It says, after how many seconds does the egg hit the ground? Well, if it's going to hit the ground, that means the height's going to be 0, right? On the ground. And they're telling us that this whole function represents the height. So if we want the height to be 0, we're putting a 0 in for f of t. So we've got 0 is equal to -16t squared plus 64. And like we just talked about, we got to factor it. Okay, I'll you go ahead and factor that. I want you to find your solution to this question. Don't forget that first step, that GCF.
Oh. How about that?
Once you think you have it, talk to somebody about it. Or if you're stuck, talk to somebody about it.
That means you have 2 seconds and not jump off of that building. But also that's right. Eli was saying that. Yeah, like,
All right, here we go. What's the GCF? What's the GCF?
-16.
-16 is the GCF. If you took anything else out, right, that's just the CF, it's not the GCF. Gotta get the greatest common factor. That's gonna leave us with t squared minus 4. Okay, because we took that negative out, that first term is negative, we took it out. We got a difference of squares here. That's t plus 2, t minus 2. That means t is either equal to -2 or +2. Which one of these makes sense? The +2. Negative does make sense. You can't have -2 seconds on an object drop. So we're looking at 2 seconds is when that thing's gonna hit the ground, right? Because we don't know what it is, right? You just said an object.
2 seconds to survive.
Does it say an egg? Oh, it does say an egg. There we go.
Oh, that's cool.
Dropping an egg, but they don't have a picture of the egg on there. I checked.
Well, it's right there. You don't see that? It's dropping the person.
Oh, I thought this was like their legs. I thought they were hanging over their head. I thought they were sitting like that. I was like, that is super dangerous. Just sitting up there. That makes so much more sense now. Yes, I thought they were sitting up on the edge of the building like that. Yeah, we get it. You're up there. Now tell me.
Get down, Buddha.
That may thank you for pointing that out. Wow.
Yeah, you are.
All right. Hey, last thing here. Last thing. Quiet, guys. Just talking about it. If the initial height is adjusted by k feet, what if we raise the initial height? What's going to happen to our answer from A? More seconds, right? If we subtract, then less seconds because we're closer to the ground. Okay?
So then it could be negative.
It wouldn't be negative. It would just be a smaller number. Right? All right, go ahead.